In data warehousing and analytics, the structuring and organization of data are paramount for efficient data retrieval, integrity, and overall performance. Central to this organization are the various types of keys used in data models. Keys are crucial elements in a database, as they define relationships between tables, enforce data integrity, and optimize query performance. Keys serve several critical functions. Keys ensure that each record within the table can be uniquely identified. This is essential for maintaining accurate and consistent data, as it prevents duplication and ambiguity. Keys establish and enforce relationships between tables. These relationships are the backbone of relational databases, allowing for complex queries that can draw insights from interconnected datasets. By enforcing constraints such as uniqueness and referential integrity, keys help maintain the reliability and accuracy of the data within the warehouse. Keys, especially when indexed, can significantly enhance the performance of database operations by speeding up data retrieval and ensuring efficient joins between tables. Understanding the different types of keys and their specific roles is essential for designing robust data models. The commonly used key types are primary, surrogate, foreign, composite, candidate, alternate, compound, secondary, unique, and partition key. These keys contribute to the overall functionality and efficiency of a data warehouse. Understanding the usage of keys aids in the creation of efficient and scalable data architectures, and also ensures that the data warehouse can support complex analytical queries and business intelligence operations. Let's delve into each key type to understand its purpose, how it is used in data modeling, and its significance in the context of data warehousing and analytics. The primary key uniquely identifies each record in a table. It ensures that each record can be uniquely retrieved and distinguished from all other records. Primary keys are essential for maintaining data integrity and enabling efficient data retrieval. It cannot accept null values, and each table can have only one primary key. It can consist of a single column or multiple columns. There are two types of primary keys: natural key and surrogate key. A natural key is a primary key that has a business meaning. The value of the key is derived from the data itself. For example, a customer ID generated by a front-end system. Natural key is an ideal primary key for tables, where the natural key is inherently unique and stable over time. A surrogate key is an artificial key that is created to uniquely identify each record in the table. It has no business meaning and is typically generated by the system. For example, an auto-incremented integer or a globally unique identifier. It is commonly used in data analytics where records are sourced from multiple source systems. For instance, the customer dimension will have customer records sourced from multiple source systems, so a surrogate key could be used for defining the primary key for the customer dimension. Surrogate key also helps in providing unique record ID when the values of dimension change. For instance, in the product dimension table, the product description could change. The surrogate product ID helps to handle and track this change. A foreign key is a column or a set of columns in one table that references the primary key in another table. It establishes a relationship between the two tables, ensuring referential integrity. For example, a sales table has product ID as foreign key that references the product table. It can also have store ID, salesperson ID, and date ID as foreign keys. It allows joining related data from different tables, essential for relational database queries and maintaining consistency. Foreign keys maintain referential integrity by restricting actions that would leave orphaned records. For instance, a product record cannot be deleted if there are sales records linked to it through a foreign key constraint. A candidate key is any column or set of columns that can uniquely identify a record in a table. A table can have multiple candidate keys, but only one can be selected as the primary key. For example, in a customer's table, both customer ID and driver's license number could serve as unique identifiers. It is used to identify potential primary keys, ensuring uniqueness before choosing the primary key. An alternate key is any candidate key that is not chosen as the primary key. For example, in the customer's table, if customer ID is chosen as the primary key, driver's license number becomes an alternate key. It is used to ensure additional uniqueness constraints within the table. A composite key is a primary key composed of two or more columns. It ensures the uniqueness of records based on the combination of these columns. For example, a customer address table where the combination of customer ID and address details uniquely identifies each record. It is useful in many-to-many relationships or when a single column is not sufficient to uniquely identify records. A compound key is similar to a composite key, but it specifically refers to a combination of multiple keys that each might be foreign keys in other tables. For example, a table that tracks loyalty enrollments where the combination of customer ID and loyalty ID uniquely identifies each enrollment record. It is used to represent relationships where a combination of foreign keys forms a unique identifier. A secondary key is a non-unique key that can be used to index records for faster retrieval based on non-primary attributes. For example, indexing customer name column in the customers table. It is used to optimize queries that search based on secondary attributes. A unique key ensures that all values in a column or a set of columns are distinct across the table, but unlike primary keys, they can be null. For example, ensuring driver's license numbers are unique in a customers table. It is used to enforce uniqueness constraints on columns that are not primary keys. A partition key is used in database and data warehousing environments to divide a large table into smaller, more manageable pieces called partitions. This division helps in improving query performance, management, and maintenance of large datasets. For example, partitioning a sales table by sale month to distribute data across different partitions based on time periods. It helps in optimizing query performance by allowing the database to read only relevant partitions instead of scanning the entire table. Partition keys are essential in large-scale data warehousing environments, providing a structured approach to handling massive datasets efficiently and effectively. To summarize, each type of key plays a crucial role in the data, warehousing, and analytics environment. Using these key types effectively enhances data model robustness, query performance, and overall data integrity in analytics applications. I hope this video has given you a good understanding of the type of keys in data warehousing. Want to learn more about data and AI? Be sure to subscribe to our channel for more insightful content.